presentation will be over and this discussion will be over. That will be followed by your assessment, and that will be a final completion of this course. Okay, so let's start today's presentation. Guys, I am audible now to everyone?
Yes, sir. We can start. You're audible.
Okay. So as we had discussed, even in the last week and in the yesterday's presentation, the most of the thing about the security and privacy issues, that what could be happen if such an incidents happen in the cloud environment. What could be a confidentiality breach, what could be an integrity breach, availability breach, and accountability breach. But how an application will execute in a cloud environment, and when an application is executing in a cloud environment, we want to execute the application to be executed in a secure environment. So what is mean by a secure environment? A secure environment means that you want to perform computation, and that computation happens over the cloud computing, over a third party cloud systems. And since the third party cloud system is a third party, so there is a trust deficit between the cloud service provider and the client. And since there is a trust deficit between the cloud service provider and the cloud user, so they don't trust on each other. If they don't trust on each other, so how a client will outsource its data and computation to the cloud server? So for that purpose, to address that issue, we will implement some mechanism, some preventive techniques, so that whenever you outsource your data or application to a third party cloud server, that must be confidential, secure, and also its integrity, means the integrity of the computation or the integrity of the result must be preserved. Okay, so let's see this, how this happen. I will explain it step by step. So by this picture, I am going to show you the outsourcing paradigm. So there is a client, and the client is, this client is a resource constrained client. This client is a resource constrained client. Resource constraints client. Okay, means it have limited computation capabilities. It have limited computation capabilities. Therefore, and from limited computation capabilities means device as shown in the picture, or it have a personal laptop computer, or a device which is not possible to perform a computation, using its own computing resources. And therefore what it will do, it will outsource this function to the cloud system, and in that reverse, the cloud system will respond with the result. Are you getting my point? But although this entire paradigm, outsourcing paradigm, looks very promising, means a needy, uh, resource constrained client wants a high end system, so he is paying something for to use the functionality of a cloud server, and in lieu of that, its computation is performed over the system. So the benefit, let's first see the benefits or the motivation, that a client is able to perform a large computation even if he lacks a necessary computational resource, even it doesn't have necessary computational resource or the expertise to perform such kind of computation, even if he can perform the computation, he can execute the computation. Further, there is no need to procure or maintain the computational resource. Means if the client is, you can say, a medium enterprise which do not want to spend money to procure or maintain its own IT infrastructure, it's better to outsource its work to the cloud computing. So there is no operational or computational cost. Further, whenever the work is outsourced to the cloud, whenever whenever the work is outsourced to the cloud, the point is that it reduces the financial cost. So how it reduces the financial cost? As you know about the outsourcing, why outsourcing happen? It's outsourcing happen because if someone offering a service, if someone offering a service more economical than producing in-house, and in this way the clients able to save financial cost whenever they are outsourcing their work in the cloud environment. Further, even it doesn't have the required software or hardware resource and even the expertise to operate them, he or she can perform the computation. There is no need to maintain such kind of resource even without a critical human resource that could be possible. As you know, a cloud service simultaneously provide you IaaS, PaaS, and software as a service. And also sometimes you may be encounter as XaaS. So if your client just need a computational resource, so you can execute or provisioned a virtual machine. If your client need a platform as a service, you can start executing the platform, the development resources, and over it you will develop your application. And finally, if someone want to directly use a software resource or software service, that is also possible. Further, an important point here is the response time. The response time, the cloud, whenever you are using a cloud resource, it will reduce your response time. Why I am saying that? The point is, like if you have a system or a single system or a multiple system, okay, it is not possible to scale up such kind of resources whenever demands increase. Whenever demands increase. However, in the cloud environment, it is possible. In the cloud environment, it is possible. So, whenever you outsource, whenever you want to execute uh, any computation, and if that computation is taking 10 hours, 10 hours to complete its execution on a single machine, on a single machine, and when you outsource this computation in the cloud environment, and in this cloud environment Rather than executing on a single machine, now you are executing this process, let's say, on 5 machines simultaneously. So what will happen? Rather than taking 10 hours, this entire execution will take somewhat 2 hours to complete its execution. So as you can see, this will, whenever you perform an outsourcing of computation, it will reduce the response time. However, despite the tremendous benefit from this paradigm, means from the outsourcing of computation and data, the outsourcing scheme have many privacy and security challenges. Okay, so the first security challenge is the cloud and the client are not in the same trusted domain. The cloud and the client is not in the same trusted domain. So whenever you are outsourcing your computation or data on the cloud, so the privacy concern is not from the client who are executing simultaneously on the cloud platform. The privacy concern or the confidentiality concern also came from the cloud service provider. Further, the underneath hardware platforms are shared with multiple clients. The underneath hardware platform or the resources are shared with multiple clients. Okay, means multiple clients are simultaneously executing on the same platform. So as we have already discussed, there is a chance of cross-channel cross-channel VM attacks, and in this way, a client can read the memory of another client and steal its data. Further, a disgruntled employee or a malicious system admin, as we had already discussed about that he or she can steal, alter the data, or even in some cases, there will be a loss of data due to the disgruntled employee. Further, there is expose or use of personal information. So this is also linked with the disgruntled employee. The employee steals the data, and if that particular data possesses the personal information, that will be also steal by the employee, and that employee will may further sell in the secondary market. Also, there is the incidence of corporate espionage, means if there are two competitor companies, okay, so they may launch such kind of attack where they are trying to confidentiality confidentially read the secret, try to read the secret of another company, and for that purpose they inject employees in the to the in the cloud environment, and for that purpose that employee go to the cloud service providers and on the behalf of the enemy company and work there and try to steal the information. Further, if any kind of breach, whether it's a confidentiality breach or integrity breach, integrity breach, such kind of breach may cause financial, reputational, and legal consequences for the cloud service provider and at the same time for the client who are using the cloud services. So how we can resolve such issue whenever a application is outsourced in the cloud environment and using its service. So let's see that. So the first solution is why not encrypt the data? Why not encrypt the data? So encryption, or sometime it's also known as transformation. I will explain the transformation word later on. So for the time being, just understand it that encryption and transformation is the same thing. So encryption or transformation techniques of data is a potential solution for this problem. However, if the data is stored in the cloud environment, then encryption or transformation could be a possible solution. But this solution is a partial solution. This solution is a partial solution because because cloud provide the data storage services. Cloud provide the data storage services, and at the same time, it also provide you the computation service. And as you know, once you once you encrypt once you encrypt a data, it's become cipher. It's become cipher, and when it's become cipher, it is not possible, or it is very hard to perform a meaningful computation over a encrypted data, over a encrypted data, or over a cipher. So what is the solution of that? So rather than going for the traditional encryption techniques, rather than going for the traditional encryption techniques, now there are few novel techniques that could be applied on the data to perform a meaningful computation. So such kind of techniques, such kind of uh, encryption techniques falls into the category of transformations. Falls into the category of transformation. Means rather than you are performing a traditional encryption using a public key, using asymmetric key or symmetric key or other encryption techniques, cryptographic algorithms, you are just transforming a data from one form to another form while retaining its mathematical property. While retaining its mathematical property, and whenever you perform computation of such transformed data over the cloud, so the cloud is not able to steal the original information from the transformed data set, and the result produced by the cloud server when returned back to the client, and then client will retransform that result, it will find the original result of the original data set. So that is the entire concept. Okay, so the challenge lie in designing a transformation algorithm. The algorithm should be like that. It must provide the robust security arrangement for the client's data without sacrificing the efficiency of the algorithm. And also at the same time, it allows the cloud server to perform meaningful operation on the transformed dataset. Means whenever you are performing a encryption over the data, so it is possible you provide a very robust encryption. Means by any mean, the cloud server or the adversary is not able to break that crypto system. Okay, so that is possible. But the point is that for such a robust system, performing a computation over that encrypted data, either it is not possible, entirely not possible to perform a computation over that data, or even if it is allowed to perform such kind of computation, it will not be efficient, or it will be computationally very expensive. Okay, so the entire objective of performing the outsourcing is that whenever you are outsourcing, you are gaining, okay, in terms of in terms of economically, in terms of computational gain. Okay, and when it's become a very complex system or very complex algorithm which takes complexity in the order of polynomials or in the order of exponential, so the entire objective of outsourcing fails. Okay, so that is why whenever you are performing or you are designing a transformation algorithm, the security arrangements must be robust so that the cloud server is not able to steal the data, and also it retain the efficiency of the algorithm. Further, it also allows the cloud server to perform meaningful operation. Okay, let's move forward. And once you had performed the security, once you have performed the security means you had designed a transformation algorithm, you had performed and it had the robust security arrangement. No other client or the cloud service provider or adversary able to steal the confidential data. Okay, and now the cloud is performing the computation. When the cloud is performing the computation, now the point arises. Now the point arises that how to handle how to handle the integrity of the data, how to handle the integrity of data, because the cloud server is not transparent to the client, and also there is no guarantee to the computational integrity. The reason being, the reason being either intentionally, either intentionally, cloud is producing a wrong result due to the malicious behavior of the cloud. Either it may be possible that cloud, the resource, the resource which is giving for this computation, which is reserved for this computation, is now allocated, is now allocated to some other high priority client, some other high priority client. So rather than executing its computation, it's terminated the execution and produced the result. Further, it may be possible that some malicious adversary which existed in the cloud environment, that adversary is affecting the quality of the result. So these are the things, is the intentional deviation from the quality of the result. Okay. Further, there is also a reason of unintentional cost, means there is some hardware or software malfunction in the system, and due to that the produced result is incorrect, or there is a bug in the logic. So that could be also a reason for wrong result. So to address this challenge, there must be a mechanism, and that mechanism is known as verifiability of the result. So what you will do, you will perform a verification check of the result to verify whether the result produced by the cloud server is correct or not. And that checking of result must be efficient, and it should never be, its complexity should never be more than executing the problem itself. So there are few design goals of whenever you are designing any secure outsourcing algorithm. So the first goal is, an outsourcing scheme is correct if the problem generation algorithm produces value that allows an cloud server to compute the result that will be verified successfully and correspond to the evaluation of the function fx on the input, on those input x, on input x. So the point is, the desired result or the intended result that a client while want to achieve while executing its function over input x, that should satisfy. Okay, so that's fall into the, that's define the correctness. Next, the transformation algorithm should be provide robust security arrangement, should be provide robust security arrangement to the input as well, as well as the output result, as well as the output result from the malicious adversary. Even a cloud service provider should not able to read the input and the output result. Then the verification scheme. The verification scheme should able to verify the correctness of the result, should able to verify the correctness of the result, and any misbehavior from the cloud service provider or any adversary or due to some other client must be detected. And finally, the efficiency. And since this providing the security arrangement to the data and performing the verifiability most of the time is arranged by the client. So that is known as the client side computation, and the computation that is held over the cloud server, that is known as the cloud side execution or computation. So that must be substantially lesser. Substantially lesser means that must be efficient than executing the problem itself. So I hope now you are able to understand what is secure computation, what is its design goal. I am coming to that. If any doubt in these in all these discussions, okay, I can take while moving forward. I can take any comment if you have any doubt on that. Okay, so let's proceed further. Let's discuss the threat model. As we discussed the threat models, when we had discussed the cloud confidentiality, cloud integrity, availability, and accountability. Now we are going to discuss the threat model from the perspective that we are going to outsource and data and application in the cloud environment. So from the perspective of the client, the threat to data confidentiality and integrity potentially come from the cloud server, potentially come for the cloud company, because it is already assumed that it is the personal data and it's the data which is held by the client. So whenever it's start outsourcing that data or the computation to a third party cloud server, at that time this threat arise. At that time this threat arise. So it came from the end of the cloud server. So mainly there are two types of threats defined. There are two types of threat defined in various literatures. The first kind of threat is semi-honest model, which is also known as honest but curious. And another kind of threat model, which is defined as malicious and untrusted model. So the first model is semi-honest model. Another model is malicious or untrusted model. So in the semi-honest model, the cloud server honestly follows the protocol, honestly follow the outsourcing outsourcing algorithm. Okay, but it secretly records the sensitive information about the data and computation. And later on, once this execution is completed, it's try to retrieve the meaningful operation from the steps. Okay. Further, the result verification is not essentially required in the model because this model says honest but curious. Means whenever a computation will perform, whenever a computation will perform, it always produce a correct result. But here the main threat is from the confidentiality issue, that it is try to secretly steal the data. Okay, let's see the another method that is known as fully malicious model or untrusted model. So this particular model is known as the strongest adversarial model, in which the cloud server may be dishonest and curious both at the same time. The cloud server may be dishonest and curious at the same time. So if the cloud server is dishonest, it means it means it will not follow the algorithm. It will not follow the algorithm. It may be deviate from the algorithm instructions. It may result random indisputable result. Further, it may record the sensitive information about the data and computation and later try to retrieve the meaningful operation. And also, when you will perform the verification, because the reason it produce wrong results, so you have implemented a result verification technique or mechanism. So even it try to convince the client that result produced by the computation is correct, and it try to deceive from the result verification step. Further, uh, there are a multiple way through which a secure computation could be performed. The first way is semi-trusted model, as we have seen in the threat models. Another is untrusted model. So to achieve the objective or to fulfill the objective of first model, which is honest but curious, means in these methods there is no implementation of verification technique. There is no mechanism of verification algorithms. So the first method is audit based model, another method is secure coprocessors, another method is multi-party. Then there are two other methods which have, so these methods provide the security and at the same time verification, while these methods only promise the secure execution. These methods only promise the secure execution and nobody is allowed to steal the confidential data, but they don't provide a verification mechanism, while these two methods provide the security mechanism and verification mechanism at the same time. So let's see what audit based models say.
Sir, I think your audio has dropped off. We are not able to hear your voice. Um, Professor Male, we are not able to hear your voice, sir. I think your audio has dropped off.
Hello.
Yeah, sir, your audio
Hello?
had dropped off. Yeah, we are able to hear you now, sir. Your audio had dropped off earlier.
Okay. Okay, maybe the two.
Yes.
Yeah. Just a minute. Okay. So, as you had seen, broadly two categories. The first one is the semi-trusted model, another is the fully malicious model or untrusted model. So, in the trusted model, what say that that only security is essential for such methods. Means there may be a issue of confidentiality in the cloud environment, but there is no issue of integrity in the cloud environment. However, there are many literatures published which say that the confidentiality is the issue, and at the same time integrity is also an issue. Okay, so first discuss about the semi-trusted model. So in the semi-trusted model, the client and the trusted workers, the client or the trusted workers recomputes recomputes some parts of, it's not come, it's some part computed by the untrusted workers. So if there is a quorum and in that quorum there are 12 or 20 members, 20 workers who are performing the computation. Okay. Once the computation has been completed, out of that quorum of 20 members, let's choose your trusted members or the trusted workers. So, and you had choose uh, as a client, so that will be the leader of that quorum. So you have choose some 4 5 trusted workers and you become the leader of that group. After that, you had performed a recomputation. Once you have performed the recomputation and produced the result, then you will compare the result. In this way, a audit based computation performed. The next is secure processor. So the coprocessor model says it is very similar to the trusted trust or trusted platform for cloud computing, TPCC, as we have discussed in the previous lectures. Okay, where I had discussed about a trusted platform in the cloud computing environment. Okay, so that trusted platform provide you an isolated environment to complete its execution. So if the environment is isolated, means the computation is performed in a complete isolated environment, no other computation is performed over that physical machine or over that server. In this way, the security is preserved. And since it's a trust platform, so it is assumed even the cloud service provider is not able to steal the data from this trusted platform. Okay, so that is the secure coprocessor. Another method, another method is secure multi-party. Secure multi-party, what happened? There are two or more parties, very similar to the audit-based computation, very similar to the audit-based computation, but the difference lies in there are two or more parties and the data is divided between these parties. Okay, so you can say that data is private to a particular party. So if there are three, four parties, say there are four parties in the data belongs to them, the data D1, D2, D3, and D. private to each party. Private to each party. So each of them will perform a separate in complete isolation. And once the result has been proved, that will be the union of for the final result time. In this way, the final result is produced. So you can say either using secure core processes or using the secure multi-party, one can achieve the confidentiality, maybe the data confidential. So in this, one can provide partial security in provide a complete security in a outsourcing environment. One has to the for confidentiality and also integrity. So for that purpose, there are two methods. The first method is interactive proof, and another is non-interactive proof. Okay, so mainly in these two methods, we will discuss about the verification, as we have already understand how we can provide security, how we can provide security to the confidential data. So in these two methods, we try to understand how we can provide verifiability to the computed result. So once the computation has been completed, means a result has been produced by the cloud server, the client will actively challenge the server. Okay, the client will actively challenge the server, and it's the responsibility of the server come with evidences, to come with proofs the result produced by the cloud server is correct. Okay, so the server reply with the probabilistic proof to the client and tries to convince him for the correctness of the computation, that the correctness of the computation. As you know, the client is resource constrained. That is why perform it cannot perform the recomputation to verify the result. Further, multiple round of interactions happen between the client and the cloud server. And finally, once the cloud server produce enough proofs to the client, that result is accepted. And in non-interactive proof, so as you see that this method required multiple round of interaction for proving a result. So that is an overhead. That is an overhead required multiple interaction between the client and the cloud server. So what non-interactive proofs say, that is improvement over interactive proofs, that it says rather than performing multiple round of interaction, there should be a mechanism that when the result returned by the cloud server, it also attach enough proofs so that the client is able to verify the result efficiently. Okay, so these are the mainly two methods through which a cloud server proves the authenticity of the result. Let's move. So now we had seen like what could be the essential property of an outsourcing method. So these four items, these four design goals are essential whenever you are designing a outsourcing algorithm. That one is correctness, another is security, then verifiability and efficiency. Means your algorithm should able to produce correct result, and the computation performed over the cloud server must be secure, the cloud server or any other adversary is not able to steal the information, then the result produced by the cloud server must be verified and checked, and only the checked result are accepted by the client. And finally, that performing all these steps, since they all are overheads, must be efficient and should be lesser than performing the problem itself. So that are the, you can say, the design goal whenever you are designing any algorithm. A very basic or primitive algorithm that we are going to discuss in the outsourcing paradigm. So so as you know, most of the data items or the data sets could be presented in the matrix form. And most of the scientific and engineering work or engineering computation is performed in the form of matrix operations. Is performed in the form of matrix operation. Okay. So the primitive matrix operations are matrix addition, multiplication, subtraction, transpose. These are the basic operations. So whenever you are performing a matrix addition, subtraction, transposition, that could be performed in the complexity of order of n square. So those who know about the complexity of matrix addition, subtraction, transpose is order of n square. That is the quadratic time complexity. And such kind of computation is performed over even on the least resource client, or even at the thin client. So the main of such operation is how to handle if the problem is a polynomial time, means order of n cube type. How such problems will be addressed. The reason to address such problem, the first is the complexity. This is the complex problem. So such kind of computation is not possible over the thin client. The reason being, if you are performing a matrix, so that is not possible. You can even check on your personal devices. Matrix is like 10,000 cross 10,000. If you are trying to use that, most possible that most of the system that we are using, it is not possible to execute such kind of computation, and very possible fault. All these problems, as you know, are the basic building blocks. It could be used in computer graphics, transformation, in graph theory, to studying the property of networks, scientific electronic circuits, quantum mechanics, economics, finance, meteorology, and also in machine learning operations. So that is why it's a primitive of, and we are going to design an outsourcing mechanism for such applications. So matrix multiplication is a basic mathematical problem, and which could be represented as m1 cross m2. Okay, and one has to verify the property that m cross n and n cross p means the number of columns in the first matrix must be equal to the number of rows in the second matrix, then one from the 10th standard. These are the basic terms and description whenever we are going to design an algorithm. At m1 and m2 are the matrix of m cross n and n cross p. So they are the rectangular matrix, and similarly, a result will be produced in m cross p. As you know that if a matrix is of dimension m cross n, the matrix is a dimension of n cross p. So when you combine both of these m cross this or cancelled out or consumed while the multiplication. So the final resultant matrix will be m cross p. Okay, and the element or the values real numbers. Okay. Further, there are other kind of permutations. As you know, if you multiply the diagonal matrix, that will produce an matrix. Then there is a permutation function and concordant of it. One more algorithm that I so that will be help you out to understand this. Just a minute. I will return back to these algorithms. Okay. So this is the matrix multiplication algorithm that was proposed by in the year 2000, in the year 2014 as 10 here. So what he says, he provide a random permutation of matrices. So while doing the random permutation and at the same time it also performing the multiplication random permutation and also try to hide the elements for with new elements in this way what happens few invertible matrices. Invertible matrices means if there is a matrix Pn, it is possible to perform an inversion of the matrix. So you know that a matrix inverse is only possible if determinant of the matrix and also at the same time then you will produce the adjoint of the matrix. Produce the P minus or the P inverse. Once you will produce the P1 and P2, okay, so these values, these random values will use to perform the transformation operation, So that will perform the randomized. So this is called transformation. This is called transformation when such kind of randomization performs. So what such multiplication will do? It will first perform a row wise traversal of element. Then it will perform traversal of elements and then multiply each element with random values and multiply with random value. Okay, so the reason by in this article is it's very efficient. Means you know that performing matrix multiplication takes order of n cube. However, due to the space of P1 and P2, and P1 and P2 are not a vector matrix, they are square matrices. And even after that, it is computed not takes make that more than order of n square. This computation not take order more than order of n square. In this way, as you can see that. It transforms first input matrix, then it transforms the second input matrix, and the result has been produced. Once the result has been produced, you can even see this result is also, so this result is returned back to the client, and the client perform this computation to finally these two values will be cancelled out, and from this way it get the result of M1 and M2. So that M1 M2 performed over the cloud system. Okay, so when the transformation happen, so as you know, whenever you multiply some entity with 0, it produces 0. So if there are 0 value elements in M and 0 value elements in the right matrix, okay, so either you are applying the square side if the data values have zero entries. So even after the multiplication, this condition holds. Zero in the input will be same as the after multiplication from the left hand side, and even after multiplication from the right hand. So in this way, the zero entries elements are exposed, and after that this method is performing traversal of elements. Means first it's perform a traversal of elements row wise, then column wise, a randomization of elements row wise and column wise. So even it perform a traversal of element row wise and column wise, still the number of zero present in the input matrix will be same. That will not going to change because you are multiplying something, and if you are multiplying something, it does not going to hide the element with zero value. Okay, so that is why it has been proved that this method, while providing while providing the transposition service, it is not able to hide the zero value element. And if the data matrix is sparse, if the data matrix is false, this method is not able to protect the confidentiality of the matrix, is not able to protect the confidentiality of the matrix. Okay, even from an example, you can see it. If this is an input matrix and the client generates the random keys alpha and alpha 2 as 1 and 2, and beta 1, beta 2, beta 3 as 3 and 4, and the random permutations as 2 1 and 3 1 2. So these are the permutation matrices P1, P2, P2 inverse, and also you can write the P1 inverse. And when you will perform the computation, you get the result as this. As you can see, the number of zeros present in X before performing the transformation and after performing the transformation is same. This means this means an adversary can clearly distinguish between the input and the output. Similarly, when the input matrix say X and X dash chosen by an adversary A, he is able to distinguish between the two values, that is T and T dash, and therefore this algorithm. So what could be a better method? What could be a better to providing a transposition? So a better method could be if the method doesn't behave on the structure of the matrices. So what does it mean? If a matrix is dense in nature, the discussed method is able to provide data confidentially. However, if the matrix is a sparse structure, it is not able to provide confidentiality to the data. So the another method says that to provide a uniform security to all kind of matrices, whether it's a sparse matrix or it's a dense matrix, a better way to provide such kind of security rather than performing a multiplication, because a multiplication is not able to hide a zero valued element. So it's better to perform a addition of element, so that will able to provide the security over the multiplication. However, sometime it has been observed the complexity of such kind of computation may be near to be the order of n cube, but it could be intelligently manipulated so that such complexity never achieved, and you can see in the computation it never reaches to the level of order of n cube, and in this way the confidentiality achieved. In this So these are all the steps of implementing the algorithm. How you can mask the values which was previously not masked. The reason is they are zero valued element. So this particular method is uniquely able to provide security and doesn't depend on the sparse structure or the dense structure of the matrix. Okay. So here the point is, when the executions are seen, means when a security analysis has been performed over this method, it has been observed that this method had the security, means in the brute force complexity analysis. As you saw, that it get the highest possible security, means of exponential time. So even if the cloud try to steal the data, he could never be possible to steal the data in computational bound quantity. Okay, means in a limited time or a time bound. Okay, so that is why these methods provide security while in the brute force method. Then the verifiability analysis. This method is able to perform the verification, and it's able to perform the verification when the verification algorithm is run for k times, and this k defines that what kind of efficiency and checkability you want to implement in the method, what kind of security and verifiability you want to implement in the method. If you are increasing the value of k, means you are performing the verifiability check multiple times over the result. At that time the efficiency will goes down, and if you are performing less number of verification, at that time integrity may be breached. So one have to decide the value of k so that the efficiency and integrity both could be achieved. So these are the efficiency analysis of the methods, and you can see that all the methods and the subsequent procedure while implementing the algorithm is never be more than order of n square, and the computation performed over the cloud is in polynomial time, means in order of n cube. Whenever a experimental evaluation has been performed, the efficiency is computed over the original operation of matrix multiplication, and then the matrix operation which is performed in the encrypted domain, the matrix operation performed in the encrypted domain. Guys, any question or any doubt? Okay, it's like we had spent already. If you want to ask anything, you can ask me.
Sir, can you check the chat?
Yeah, I'm looking on that. Yeah, many times it requires to build algorithms. Okay, whenever you want to achieve a certain kind of security. Okay, so there is a lot of research going on where, uh, as you know, in the security domain, the first thing was to provide the data security. To provide the data security, it never be thought or never be realized where the research go on in the direction where people try to achieve people try to achieve a application security. Means what could be if we were able to perform a computation over disguised data. Yeah, these kind of implementations you can it is not from the cloud service provider. These kind of implementation from the clients who want to achieve such kind of security, or who want to implement such kind of security on their application. I can share a few articles if you want to read those articles. Those articles are very interesting. Okay, and it is not only to the primitive operations. It is not only primitive operations like matrix application or matrix addition, matrix multiplication, determinant. Even now the concern goes on after a lot of incidents of confidentiality, is that whenever a data analysis happen, the analysis should be in a private domain. Means like a data should not be disclosed to the directly to the guy who is performing the analytics. So all kind of machine learning algorithm, since it is like people have achieved a certain level of accuracy in the machine learning or in the deep learning. So the next stage is that whenever a financial analysis, a health related analysis, or a personal information related analysis is going on, that must be over a data which is in encrypted. So such kind of things going on. You can even search articles just typing on the Google, like privacy preserving machine learning techniques. Privacy preserving machine learning techniques. Just go on, explore those topics. These are the new techniques or a new dimension of research. There you can find out many articles over it, even in reputed conferences and journals like IEEE transactions. Okay, you can find out these articles. Any other question? Anyone else want to ask anything? What is mean by that? Do we really use ML here? I'm not able to comprehend your question, what you want to ask.
Sir, this is Sri Krishna. This is more specific to when I looked into this Amazon services and the built-in and everything. Uh, we use mathematics to some extent and programming some extent. So how do we see that ML is inculcated? That's a broad question I felt to just understand my clarity.
Can you repeat your question again? Actually, uh, the point is machine learning is entire another domain. Security is an entire another domain. Okay, means security was observed to provide the confidentiality of the data. It never be realized that there is also a way through which we can preserve the integrity of the computed result. Okay, so I am giving you an example through which maybe you will able to understand. Let's say you are trying to find a way, a road from one place to another place, or going from one place to another place using the Google Map, using the Google Map. Guys, just a minute. I am get back to you. Just give me a 1 minute. Sorry for the interruption. I was replying to an answer and try to quote an example. So the example is that you are using a Google service, and in that Google service, what you are doing, you are trying to go from one place to another place. So in this way, you are revealing to the Google, that you are going from this place to another place. Okay, so that is a way So we never thought that that particular information could be used for could be used for uh, to plot some kind of malicious activity. So rather than keeping yourself, you can put some uh, a very big person or something like that. So his identity is revealed there, and also his plan is also revealed in the real time to the Google. Okay, so if someone try to steal such kind of information to plan or execute an attack, so he can do so. So a research article has recently published with an I think by MIT or Berkeley, something like that. What they are doing when you are performing a search in the Google Map to go from one place to another place, so those search are even encrypted, and also the location is identified by uh, uh, the GPS that is also encrypted. Means Google is giving you the result, and all the information that is shared by you with the Google servers, those are also encrypted. Means all the computation happen in the encrypted domain. So these kind of applications are required in the market. And also, as you know, there is pandemic going on. So the health related information cannot be disclosed where a person can be identified. Means a personal information cannot be disclosed for the analysis purpose, but at the same time analysis is also important, so that a relevance or correlation can be established, so that a better treatment or better provision and better mechanism could be implemented for the prevention technique. Okay, so at that time uh, computation over the encrypted domain become important. I hope you have get the answer. Okay, guys. So let's continue. Yeah, that is equally possible. Nobody knows what is going on or what is happening inside the cloud server. You have just shared your information with them, and what they are doing with your data. As many places, it has been quoted that Google know more than you what you know about yourself. So this quote is at many places. So what they are doing with your information or with your data, nobody knows. It is not transparent to anyone. And neither any of us have time whenever we are signing to their account. So what is the usage of the data that we are disclosing to a particular vendor? Okay, guys. So as I had discussed how you can perform a secure computation. So, and what is important in a secure computation algorithm. Now there are and discussion, and maybe you people are not interested in that, and even I don't want to like that is not important for this particular presentation. The point is here is like how you are able to design a new algorithm for a new application. Okay, so that application could be an SVM application. A support vector machine means you want to perform a privacy preserving machine learning. So a machine learning algorithm could be a SVM algorithm, could be a naive-Bayes algorithm, could be any other algorithm. Okay, so such kind of new algorithms are coming in the market every day, where either the algorithm has been changed, means either the security algorithm has been tweaked or modified or enhanced for provide robust security or to increase the efficiency, or the next is either they perform a privacy preserving over a new kind of machine learning algorithm. So that's all in secure computation from my side. If you want to ask or want to discuss anything, we can do that.
So with this, are we done with the course sessions for both the sessions that we had today?
Looks like once again we lost him.
Professor Malay, your audio isn't, it's dropped off again.
Okay, I'm coming. There is some network issue. Is there option? Yeah, guys. Any other question you want to ask? Yeah, like even like what kind of if you want to see any confidentiality breach that happen, you can just Google it out. You can find out on the CERT database, as I had discussed in the previous presentation. A few issues you can see that many number of issues happen. Just type it, issues happens around the globe. You will find those kind of issues in the real time. Yeah, it is possible to choose in AWS algorithm in AWS. What kind of algorithm you want to choose? Can you tell me? Like there is a question: is there option on AWS to choose algorithm? What kind of algorithm you want to choose, and for what purpose? If you are hearing me. That will be answered separately. I don't know how you get certificate. Like after the assessment, anyway, that is the process. Once this entire presentation will over, then you will give the assessment, and if you pass the assessment, you will get the certificate. No, it is not any promise. Okay. Uh, in the SLA document, they make agreement with you that they are implementing the most stringent security mechanisms, but still uh, the hackers or the adversaries find a way to perform an attack. Actually, there is a continuous competition is going between the cryptographers and the cryptanalysis, or you can say that the person who are designing the security system and the person who are breaking the security system, and this competition will go on forever. Whenever there is a system, and if the system is connected with an internet connection or share is information over the internet, there will be always a possibility of security breach or an attack on that system. It could not be possible to design a system which you can say is 100% safe or 100% secure. Okay, guys. So that's all from my side. Okay, and I hope you people have enjoyed all my lectures.
Thank you so much, sir. I hope, Professor, with this session, we have completed the entire coursework for
Yes,
the sessions.
yes.
Okay.
Like I had completed from my side each and everything that is I had given in the brochure. Okay, and that assessment has already been sent, so that could be shared with the students. Okay,
Yes, Professor,
and
definitely. Also,
yeah,
sir, what would be the passing percentage for the assessment?
uh, what is the standard? Like you people could decide on that, and there is no foundation from my side.
Okay. So it's usually, sir, basis, I mean, according to the professor who's prepared the course, basis the difficulty of the assessment, they keep a passing percentage.
Make it 55%. Okay,
Sure,
55% is okay. Yeah.
sure. Okay, thank you.
So if you all the student who get more than 55 marks will award the certifications.
All right. Thank you so much, Professor. Should I share the assessment now?
Yeah, you can please share with them. And also, please let me the feedback once the entire uh, assessment will complete. And I want to see like what kind of marks the student has achieved in that. Okay.
Definitely, sir.
Okay. Thank you, everyone. Thanks for joining.
Thank you so much, Professor, for conducting these sessions and for taking all the queries so patiently. I'm sure the students would have benefited a lot from these sessions. Thank you so much.
Thank you, everyone.